Compare the domain and range as well as any intercepts, if they exist, of the functions graphed below. Write domain and range as inequalities, intervals, and in set builder notation. Okay, so first looking at our graphs, let's point out the restrictions here. So with f of x, we see it's an exponential equation, and so it will have a horizontal asymptote. And we see from the graph here that it comes really close, but it will never actually touch this line, y equals -3. And that stems from the fact that 10 to the x, in this case, will never be able to equal 0. And so that could never be a 0 minus 3, which would never give us -3 for f of x. So there's our vertical asymptote, horizontal asymptote. And then with our log, then we see it's the opposite, and it has a vertical asymptote at x equals -3. Okay, so and notice also that in these equations we have a -3, which just told us that the whole graph was shifted down 3, and with the log, then we have the x plus 3, which means the graph was shifted to the left 3, and again, that's because x plus 3 can never be negative, because you can never have a negative in a log function. So there are our asymptotes, and now let's just point out our intercepts. So for f of x, we see we have an intercept at 1/2, 0, and then our y-intercept is at 0, -2. And then looking at our x-intercept of our g of x, we have -2, 0, and our log at 0, 1/2. And so notice that our x-intercept and our y-intercept of the different functions are the same except for reversed x and y values. So that is an inverse property. Now let's go ahead and write down our domain and ranges as well. So we see that with exponentials, we have unlimited, unrestricted domain, just from -infinity, it keeps going left, and then to +infinity, it keeps going right. So we can write that down in inequality form as -infinity is less than x is less than infinity. And then in interval notation, that'd be parentheses -infinity to +infinity. And then in set builder notation, that'll be the set of x's such that x is a member of the real numbers since it's all real numbers. Now for the range of f(x), we know that it has to be greater than -3 since it will never touch -3 and then it just gets higher and goes up from there. So it's going to be -3 is less than y is less than infinity. And then in interval notation, -3 to infinity, making sure to use parentheses since we can't touch -3 and then infinity is not a set number. And then with our set notation, then it'll be y, the set of y's such that y has to be greater than -3. And here we just have to put what y is bigger than. We don't have to put that's less than infinity like we did in the inequalities. Okay, so the domain and range of g of x, domain of g of x is the thing that's restricted here. So we know that it has to be bigger than -3 since it never touches -3 and then it goes right from there. So it'll be -3 is less than x is less than infinity. And then in interval notation, -3 to infinity. And then in set builder notation, the set of x's such that x has to be greater than -3. Okay, now for the range, that is unlimited since it's all real numbers, since it goes down to infinity and since it goes up to infinity. And so that will just be -infinity is less than y is less than infinity. And then -infinity to infinity with parentheses. And then the set of y's such that y is a member of the real numbers since it's all real numbers. Okay, so we can conclude from this that this is also property of an inverse because our domain of f of x matches our range of g of x and vice versa. And so we can go ahead and summarize our answer. These functions are inverses. The domain of f of x is all real numbers. As an inequality, this is written -infinity is less than x is less than infinity. As an interval, -infinity to infinity. And using set builder notation, the set of x's such that x is in the real number set. The range of f of x is restricted by the horizontal asymptote y equals -3. The range is written as the set of y's such that y is greater than -3 in set builder notation, -3 to infinity as an interval, and -3 is less than y is less than infinity as an inequality. The domain of g of x is restricted by the vertical asymptote x equals -3. The domain is written as the set of x's such that x is greater than -3 in the set builder notation, -3 to infinity as an interval, and -3 is less than x is less than infinity as an inequality. The range of g of x is all real numbers. As an inequality, this is written -infinity is less than y is less than infinity. As an interval, -infinity to infinity. And using set builder notation, the set of y is such that y is a member of the real numbers. The x-intercept of f(x) is close to 1 half 0, and its y-intercept is 0, negative 2. The x-intercept of g of x is negative 2, 0, and its y-intercept is close to 0, 1 half.